Pressure is the amount of force over a unit area. At sea level, we are under 14.696 pounds per square inch at standard atmospheric conditions. This is due to the height of the atmosphere and the weight of all that air above us. Absolute values start at 0 for whatever it is that you're measuring. So if pressure is a measure of force per unit area, when there is no force at all, the absolute scale would be at 0. And the number would increase from that point as the pressure increased. So our gauge value at sea level is 0. Why? All we've done is shift our 0 point. Let's imagine we're 50 feet deep underwater. Using our conversion, if 1 foot of water is equal to 0.4332 pounds per square inch, then at 50 feet deep, we are at 21.66 pounds per square inch gauge. That is the pressure exerted only by the water that is over us here. So that is just due to the weight of the water. But that's not the total pressure or the total amount of force on our bodies. Why? Because we still have the weight of the atmosphere to consider. Now this is correct as a gauge value to say that we are at 21.66 pounds per square inch gauge, with our 0 point being atmospheric pressure. As an absolute value, we would add the atmospheric pressure to the gauge value because the units are identical. A pound per square inch is a pound per square inch. We would add our atmospheric pressure. So as our absolute value would be 36.36 PSIA. Right? So all we've done is shift our 0 point. Gauge is 0 at atmosphere. So this is what gets a little confusing for some people. It's the vacuum scale. So vacuum is also 0 at atmospheric pressure, but the value increases as we get closer to a perfect vacuum. Where does that come from? Well, it comes from here. This is a barometer, and this dish here is full of mercury, Hg for mercury. Before we start this pump and begin to draw all the air out of this cylinder, our mercury level is at the very bottom of this scale. So inside here and outside here, the pressure is the same. We have 14.696 pounds per square inch absolute here. Well, it's the same there. The air pressure is the same both inside the cylinder and out. So let's say we start to draw some of the air out of this cylinder. And we draw, let's say we draw out about enough that we have decreased the absolute pressure here to 10 PSIA. So now here we are at 10 PSIA. Oh, sorry. Here we are at 10 PSIA. Well, if we started measuring our gauge, if we had put a gauge on here just before that, and if that gauge could go negative from 0, then we would have decreased, right? The gauge would have been 0 at atmospheric pressure, but we would have then decreased to negative 4.696 PSIG. Well, while we drop the air pressure there, the level of mercury has risen. Rose up about so high, which is 9.561 inches in height. This is the height of vacuum we've achieved. So when we're measuring inches of mercury vacuum, we're measuring how high up the mercury has traveled as a result of the drop in pressure inside of the cylinder. So if we did another, we say we pumped some more air out of this cylinder, and we have now dropped the pressure in the cylinder to 5 PSIA. Well, the gauge pressure would have changed as well. It would have come down. It would have dropped to negative 9.696 PSIG, because again, we started taking our measurement at atmosphere. This gauge was 0 at atmosphere. Well, the level of mercury has also risen, and it's now come up to 19.741 inches in height. Because remember, this is our vacuum reading. So you can see this number is positive. Our inches of mercury vacuum, the number has gotten higher as the vacuum has gotten deeper. We have removed more air from the cylinder, and the column of mercury is moving up. So another way to look at pressure scales is comparing it to another known scale. So we're all familiar with measuring length. When you're measuring the length of something, anything, we can create this arbitrary sort of object that we're measuring and use familiar units. So we can say that the object actually begins here, doesn't extend any further. If I wanted to compare our pressure scales to other familiar scales, as in measuring length, right? Comparing inches to centimeters or the like, we can say that the absolute value, the 0 point, is the beginning of the object and increases from that point onward. So this is our beginning point 0, and the number can only get more positive. We can compare that to placing two rulers with the zeros towards each other, where you can see again the units are the same, but we've basically shifted our point of reference, or our 0 point. So we could say this is like a gauge value. So we flip this ruler around. So here we are at 1 inch, decreasing towards 10 inches, this value becoming more negative. And then from here, we put another ruler and it becomes more positive. And we can continue on becoming more positive that way. And then the vacuum scale, we could compare it to taking, well, a centimeters ruler and then flipping it the other way also, but the number can only become more positive. We're measuring the same thing. We've only shifted our point of reference and changed our units of measurement. Whereby, if I was at the 7-inch mark here, I would be at the negative 3-inch mark here in my gauge reading. Which would correspond to another number here, roughly 7 centimeters.